8 February, Thursday. Okay, 20 marks, 30 minutes only. Chapter 1. Right? Very complex. One chapter only. So AMATS, I know we have not yet started on it. Okay, but the date has already been decided. In week 8, 22nd February, it is a Thursday also. Likewise, 20 marks, 30 minutes. Okay, when we enter AMATS, listen carefully. When we enter AMATS, right, we are not going to be directly following the sequence in the textbook for chapter 1 and 2. So chapters 1 and 2 will be reorganized, okay? So therefore, for the chapters tested, it will be chapter 1.1, 1.1 and 1.2. Okay? So that is the reason why I said that, because it is not a sequence. Okay? So we are going in this particular sequence, 2.1, 1.1. Okay? Many of you have been asking me when are we starting AMATS. We will start AMATS after we finish chapter 2 of EMATS. Okay, give me some time, alright, to organize the document, okay, so that I can give you a brief outline over when to expect to do AMATS, when to do EMATS. Okay, I think some of you will have that document itself. Okay. Right, so that is what you can expect when it comes to doing both E and AMATS, right? It will take some time. So, for example, when we go into term 3, right? Okay, after we will finish our EMATS syllabus at term 3, following from there is just AMATS all the way. Okay, likewise, when it comes to Sec 4, we only have 4 chapters left for EMATS, and then it will be AMATS. We will be chapter 4 okay. Alright, so that's for WA. Next, I realized after dismissing your last week, I forgot to give your homework for graph sketching. Okay? So I'll just assign homework for graph sketching first. In fact, it's already stated in your worksheet. That will be exercise 1D. Let's go page 28, question 5 and 7. Okay? I'll give the deadline later on after I finish up chapter 1. Mostly already done for home-based learning last week, so I see that most of you have already done it. I'm just not sure Farid have you completed it or not. Okay, because last I checked this morning is still not yet completed. Okay, then can you please make sure you get it done today, right? Otherwise, you can face the effect. Okay, now so I went through the questions that some of you submitted. Okay, pardon the spelling from your friend over here. I just screenshot. Okay, so somebody asked, alright, in the question, okay, why is it that for question 5, part 5, why is 9.4581 cm squared coincidentally also the same meter squared? So don't quite understand. So let me bring out the question here. Okay, it is the one in this triangle. If you recall from the video, okay, I want to bring our attention to the first sentence. So in the first sentence, cases. Okay. Right, so if you recall from the video, I also drew this exact same diagram. Okay, just that this is in blue color. Right? It has a scale of 1:100. Right? So in part 5, the question wants you to find the actual floor area that the structure occupies. So the floor area is actually this square over here. Okay? So upon finding out the x value, which you did in part 3, and also rejected one of the answer in part 4, alright, you will be able to find that the value of x, sorry, I don't recall what's the value of x. Someone provide me the answer. Does anyone have it? The truncated 1.5450. Okay. So you found the value of x to be this, but the triangle base here is actually 2x. So 2x will be 1.5450 times 2. And that will give us 3.09. Okay, that is in cm. So the area of the square is 3.09 times 3.09. And that will give us 9.5481. Right? Okay? But that is the area of the square of the model. Okay? Now we want to know what is the area of the actual size thing. So we have to go by this scale over here. It says that, if you remember how to use the scale, 1:100 would mean 1 cm on the map represents 100 cm for actual. Okay, it must be of the same unit. And 100 cm is actually 1 meter. Okay, so that is the scale. But this is an area, you cannot use a length scale to convert your area. So in area wise, 1 cm squared, or to be precise, it is 1 square cm squared, will be representing 1 square meter squared. For which when simplified, it is 1 cm squared representing 1 meter squared. Which explains why the actual area, okay, is actually also 9.5481. Because 9.5481 cm squared would be 9.5481 meter squared. You understand? So it is a result of the scale. Okay? Questions? No, you get it? Okay, okay. Yeah? So that is from one of your classmates. Next question from another one of your classmates. I erased already, yeah? Okay, because it's the same thing presented on the videos. Alright, another of your friend asked, in a word problem where the variable for the roots, so that means the x values, okay, when the x value represents the velocity of an object, and one of the roots is negative, how can we explain why one of the solutions must be rejected? Okay, first of all, I believe our whole class takes physics, right? We understand that velocity is a vector quantity, correct?
Yes.
Yeah, have you learned that?
Yes.
So, scalar vector, correct? Okay, what's the difference between scalar and vector? Huh? So that first chapter of physics. Oh, never. Okay, I guess physics has been very different nowadays. Huh? Not ready? I'll ask Miss O. Your Miss teacher also, right? Okay, never mind. Okay. It's okay if you haven't learned. Okay, but right, in physics, likewise in maths, they're applicable. Okay, you will understand and learn about scalar quantities and vector quantities. Scalar quantities don't take direction into account, vector quantities take direction into account. Okay, how do we differ between them? We have your speed and your velocity. They seem to be the same thing in English. Okay, talking about distance divided by time. Alright, but then okay, they are differently defined. So velocity velocity is a quantity that takes into direction, for which it matters whether it's going to the right direction or left. And how do we defer that in terms of a numerical form? We add in a plus or minus sign. Okay, so sometimes minus sign will be when we take direction to the left. Okay, my left is here now, right? Then, so therefore, velocity can be negative, but in general, when we talk about speed, okay, speed cannot be negative. Okay, speed can only be positive. Alright, so how do we go about explaining? We just have to say that speed cannot be negative, hence we reject the negative value. That's all we need to say when we explain something. Okay, there isn't much deeper reasoning behind it. Right? So, I hope that addresses this question. Now, my focus today is I want to go through 2 more new questions. Okay? So let's take a look at what example 16 in your textbook. I think it's on page 32. Okay. I know that the answers are already printed in your textbook. However, it's important that we know how to go through and understand the question. Hence, I'm trying to explain it here. So it says here that if I throw a ball into the air, the path of the ball will be modeled by this equation, where t in seconds is the time from the moment the ball was thrown, okay, and h in meters is the height of the ball above the ground. Whenever you encounter a problem sum like this, it's important for us to pay attention to what are the units being used for the quantities being defined. Okay? So that just in case they expect a conversion of units later on. Okay? Question asks, find the difference in height between the ball and its highest point and the point from which it was thrown. Okay? So this statement itself requires some interpretation to the context of the question. Okay? So you must understand how balls are thrown up. I'm sure you're just in PE, you might have thrown some balls before and you know how it looks like. Okay, the projectile motion. So let's say you have this as your ground level. In case you have never played with a ball before, okay, it will go in such a motion, right? Okay, and we see that this shape itself, okay, is rather similar to your quadratic function, where it is a negative coefficient of your x squared, or in this case t squared. Okay, so this is the start, this is the end up. Okay, I don't think your force is straight enough for it to go sink into the ground, right? So h in meters is the height of the ball from the ground. Okay, the height itself is always measured vertically. Okay, so we are looking at all these values. These are the height. Okay, so from different positions of the ball, right? Okay, this is how we measure the height itself. We want to find the difference in height between the ball and its highest point. So the highest point will refer to the maximum, which is the turning point, and the point from which it was thrown. Okay, so this measure of height we want is actually this difference over here. So it is a vertical distance. We're not trying to measure from this point to this point in a diagonal manner. Okay, so I want us to be clear about that. Okay, so this is what we want to find. And we know that it is easy for us to determine that the moment I know what are the coordinates of the highest point and the y coordinate, okay, because if you imagine having a set of axes being put into place here, okay, the corresponding y coordinate, right, based on this function, will be able to give me an answer to this. Right? So the highest point, this difference in height, is actually the y coordinate of the turning point. Okay. So to find the y coordinate, since our focus is on the turning point, alright, the logical approach would be to consider completing the square for the function here. Okay? Of course, you can find other ways to determine your y coordinate, right? But it may not have given you a very exact answer like yes. Okay? So our focus is on turning point. We make use of completed square form. So when upon doing completing the square, we first factorize out the negative. Right, so we get that in our completed square form. Okay, so the y coordinate of the turning point is actually 5 because we know that it happens when the square is actually equals to 0, but that is not our concern here. Okay, so to find the height, it will be 5 meters. Okay, meters because the question to us that height is measured in meters. So therefore, the required height equals to 5 meters. In the event where the question maybe extended it to us, okay?
Wait, but it's saying between the difference, but you're saying between the y intercept. Because it doesn't mean the first two. So you mean when the first one meant y intercept.
Okay, we think about what the says, okay, maximum height. Okay, I think you see your textbook, you also know that this is not an answer, right? Alright, I'll talk about that one. Okay? So, is it right for us to say that it's 5 meters? No, right? Okay. Yeah, I was too absorbed to thought about it. Okay? Why? Because actually my ground is not accurate also. Okay? Because what is the height when time is equals to 0? It is actually equals to 1. So, when t equals to 0, h is equals to 1. That means that my ball was not thrown right from the ground. That means that the ball was thrown from a certain height. Okay, possibly looking something like that. Okay, so we are actually not trying to find the highest point to the ground. That would be an incorrect assumption. We are looking at the y coordinate of turning point minus away the height that it was thrown at. Okay, because when time is equals to 0, that's where the ball was thrown. Okay, it was at a height of 1. So the question is asking us to find out what is the difference in height. So, therefore, maximum height. Required height. Okay, it will be 4 meters. Okay. Questions? Okay. So I wanted to extend the question, but let's forget about it. Can I move on to the next one?
Wait, fire in the hole. Fire in the hole.
Move on. Yeah. Next one. Which is also the last one for jump off a platform with a bell that is 3 meters above the ground. Okay? So I'll draw the diagram here. We have a ground. Okay, and then there is a bell that is 3 meters above the ground. I'll just use the cross to indicate the bell. Okay, I don't know where is this platform first, so I'm not drawing it in. Okay, the path of a jump can be modeled by this equation, for which we observe that coefficient of x squared is negative, which will mean that we should expect a shape like that on the jump. Okay, in fact, nobody jumps like that one. Okay, I think that one needs a roller coaster, otherwise your skateboarding, what's that called? Platform, is it? Okay, so where x is in meters, is the horizontal distance from the edge of the platform, and y in meters is the distance from her feet to the ground. Okay, given that Barney is 1.6 meters tall, determine if she will be able to reach the bell if the platform is 1 meter away from the bell. Okay, so if the bell is here, we're looking at a distance of 1 meter, okay, away from the bell. So I will expect that it is something like that. Hang on. Okay, so I'll draw a stick person. Okay, 1 meter away. So this one is Barney. Meaning Barney is female, so I'll draw some hair. Okay, and then she's 1.6 meters tall. Okay, and then this part here is the platform. I really don't know how high is the platform. Okay. I will want to draw in my x and y. So y is actually defined with the distance from her feet to the ground. So from her feet to the ground, this is y. Okay? And then x is actually the horizontal distance from the edge of the platform. So horizontal distance will be like that. So depending, okay, of how she jumps, this is how it looks like. In fact, will I be able to know how tall is the platform?
Yes.
How? How do I know the height of the platform? Sorry? Y-intercept. Yes, so it's a y-intercept because, right, okay, Barney actually starts off at here. X is being defined to be the horizontal distance from the edge of the platform, okay, to where she is. So when she's at the platform itself, what is the horizontal distance? What is the x value? 0, right? Okay, because she's at the edge of the platform, she hasn't jumped yet. Alright, so when x is equals to 0, I can find that y will be equals to 0.5. Okay, so I will be able to tell that the platform is actually at a height of 0.5 meters. Okay, I'm going to be expecting that Barney actually jumps in that shape, so I'll just draw a certain shape, okay, like that. Right, it does not mean that the bell is the highest point. We're just trying to check whether Barney is able to reach the bell or not. Okay, it can be her body reach the bell, her legs reaching the bell. Okay, it need not always be the top of her head reaching the bell. Okay, so it might look something like that. That's the motion of the jump. Okay, so the big question over here is, how will I be able to determine if she is able to reach the bell curve. How will I be able to determine? Okay, oh, the bell is 3 meters above the ground. I haven't put that information in here. Okay, so this information here, bell is 3 meters above. Okay. Right. My question here, if you listen carefully, it says, my question is, how will I be able to determine, okay, or justify that Bunny is able to reach the bell? Yes.
3 minus y is equal to
3 minus 1. 3 minus y. Okay.
It's less or equal than 1.
So, hang on, 3 minus y is greater than 1. How do you get this idea?
Less than 1.
Less than 1. Why less than 1?
Cos
1 meter is a horizontal distance, 3 is a vertical distance. I don't think it can be inequality like that, right? Okay. So I don't think that works. Sorry, wait, I'm just trying to think of what question do I need to ask you so that you know how to do this question. Okay. Okay. So we want to determine if she will be able to reach the bell if the platform is 1 meters away from the bell. Okay. We need to know in this particular case when x is equals to 1, okay, when x equals to 1, what is the height that covers, okay, where Bunny is? Because this blue curvature over here, this blue curve, is actually Bunny's entire jump. Okay, it's Bunny's entire jump. So if I know when x is equals to 1 meters, okay, what is the height that Bunny is at? Alright, I will be able to, from there, take the value and compare it with these 3 meters to know whether Bunny is able to reach the bell or not. You agree with what I'm saying? Okay, so let's see. When x is equals to 1, okay, so when x is equals to 1, we see that the value of y is 1.5 meters. Okay, but what does 1.5 meters mean? Right? We said that y is referring to the distance from her feet to the ground. Okay, so that means that when x is equals to 1 meters over here, her feet is dangling here. Okay, I don't know how to draw feet, but okay, her feet is dangling here. The distance from the ground is 1.5 meters. I know that my diagram doesn't quite show it very well. Okay, but I want you to be able to imagine that her feet is actually 1.5 meters away from the ground. But what is the justifier? Okay, what is the thing that will actually determine whether she can touch or not? It's not about her feet, right? Her height is the thing that's important. So any part of her body, so long as it's able to touch the bell, that means it can touch the bell, right? So from here, ground. And that is greater than 3 meters. You see? Okay, it's greater than 3 meters. So that means that, will she be able to touch the bell? Yes. Okay?
What if we overjump?
It's okay if you overjump.
No, like literally I'm taking a
Okay, maybe I finish this part first. Any questions for this part first? Okay, I think just now you asked a quite interesting question. Let's think about that. Can I just add on to what you actually said? Alright, so he said that what if Barney actually overjumps? How would that actually look like? So if Barney overjumps, what kind of value would you expect for this one? At least 3, right? Okay, it needs to be at least 3 meters for it to say that it overjumped. Okay, so if it overjumps, then I think we actually say that she's able to touch the bell. No, right? Okay, so I don't think it's fair enough to say that if this is greater than 3, such that her entire body is 3 plus 1.6, 4.6 meters. So our body will be way above the bell already. So totally missed the bell. Okay, so I don't think you can say that she can touch the bell. Questions? Questions? One, okay. Exercise 1.6. Homework, okay. Let me give you this worksheet first. Okay, now exercise 11, that's 1E, not 11. Exercise 1E, the questions are stated in the worksheet there as well. Question 4, 7, 8, 11. For 11, I just want you to refer to the question below. Why? Because I know that it's troublesome to draw graph. I've already plotted it out for you. Okay, say right? The reason why I did it is also because for this particular graph, it is very challenging when it comes to plotting. I tried it myself, right? I find it challenging. And I don't think that is my intention to assess your graph plotting skills, which I've already given as homework already. Okay? For exercise 1E, question 11, my purpose of this homework is to make sure you know how to read the graph according to context. Okay? That's the reason why I gave you the graph already. Okay? So I want you to answer question 11 in the blanks provided in the worksheet. You understand what I'm saying? Okay. Otherwise, everything else, do it on foolscap paper. I would like your homework to be submitted by Wednesday. Is that okay? Yes, today's Monday, right? Thursday? Thursday better?
Everything's
So we are sending on Thursday. There shouldn't be any excuse that cannot complete your homework. Neither should there be any excuse that cannot draw the graph because graph already printed for you. Okay? Alright, so chapter 1 completely done. Okay, and then you are ready for your WA1, I guess. Okay, we're going to chapter 2 now. Ready for chapter 2? Okay, chapter 2 is a fairly short chapter. Okay, it relies on what you have learned about inequalities previously. So we just do a very quick recap about our linear inequalities first. Let's just recap by using a very simple inequality. We obviously know, if nobody knows this, okay, I think it's questionable why you're doing here. I think we all agree that 24 is greater than 4, right? Okay. So what happens if I were to minus 2 in the inequality? When I subtract 2, okay, we cannot do subtraction first. When I add 2 to the inequality, 24 plus 2, I'm going to get 26. 4 plus 2, I get 6. Okay? And we know that 26 is greater than 6. So no change in inequality sign. Right? This is what we already learned. What if I subtract 2? Okay, I'm going to get 24 minus 2, 22. 4 minus 2, I'll get 2. Okay, and we obviously know that 22 is greater than 2. I just anyhow give a number. I anyhow throw it down. You want me to give a different number? Okay, yeah. This one is just I anyhow set it up. If I add a number, this is what happens. I minus the number, I get this. Okay? And we also observe that there's no change to inequality sign. Okay? Then what if I multiply by 2? Okay? I'm going to get 24 times 2, that's 48. 4 times 2 is 8. Which we also know 48 is greater than 2. Also no change. Okay? But when I multiply by a negative 2, okay, I'm going to get a negative 48 and negative 8. And we know that negative 8 is the one that's greater. So our divided by 2, I'm going to get 12. 4 divided by 2, I'll get 2. Inequality sign is this way. No change from the original. And if I were to divide by a negative 2, I'll get negative 12 and negative 2. Okay, for which we know negative 2 is greater. So the inequality sign flips. Okay, so these are properties of inequalities that we must be familiar with. And very importantly, for inequalities, you can only add, subtract, multiply, divide. You cannot square root in the inequality, but right, you also shouldn't be taking square root, okay, in the equation also lah, right? That's for another day. Okay, so for inequalities, the only operations that we apply will be plus, minus, times, divide only. Okay, that we must remember, right? So let's just recall certain example. Okay, let's use practice now 1. Okay, let's take a look at maybe part C. To recall how to solve a linear inequality. Okay? How do we solve this inequality? Open the brackets first. So we will have 4x plus 6. Okay, then we put all the x on one side, right? Just like how we do an equation. Okay, and then we have x greater than or equal to 6. Okay, so that's how we solve an inequality. In inequality, there's an entire range of answers. So all the answers that are greater than or equal to 6 are valid solutions to this inequality, which explains why. Okay, in your typical exam format, there is always your answer blank. We should write the entire thing down. Okay, it's not just the number 6. Remember, because it's a whole range of answers that are solutions to this inequality. Then if we were to look at part D, we have 2x plus 5 less than or equal to 6x minus 13. So independent of how you go about solving it, if let's say you put the unknowns all the way on the left side, and then the numbers onto the right, we will get 2x minus 6x less than or equals to negative 13 minus 5. And we have negative 4x less than or equals to negative 18. So to find the range of values of x, we will divide by negative 4 over. And because we are dividing by negative 4, inequality sign flips. Okay? So x is greater than or equals to 4.5 or 4.5 in this case. Okay. I hope these are not unfamiliar to you. Yeah. No need. So you want, you can have it on the right. But usually we read from left to right. Sorry, 5 by 30. So you put in the other side, is it? So like 5 plus 13, 1 equals 6x minus 6, like that. Okay. Yeah. Just that when your end result, you will get it like that. Yeah. Then that's just, it's the same equivalent. Okay. Okay. The main objective of this topic is for us to understand compound inequalities or your simultaneous linear inequality. Okay, so we are going to learn how do we solve inequalities simultaneously. We have already learned in Set 2 how to solve equations simultaneously. We want to talk inequalities, so that's our objective. But before that, we need to be familiar with certain languaging issues when it comes to mathematics. So I gave you two statements.
What? No.
Bro, I suck at English and Chinese.
Okay, I'm giving you two statements over here. Okay. Let's say we are in a situation where you failed your maths.
Oh, it's the best option. First
Okay.
best option.
So if, let's say your parent tells you this, statement number one, is your phone going to get confiscated? Okay. If your parent give you second statement, is your phone going to get confiscated? No. Okay. So that's the difference between O and N. Okay. You get that? Right. So O simply means that's one of the options. Okay. Whereas N means that both must happen in order for the result to happen. Okay. So that is how we distinguish between O and N. Let's get into the objective of the lesson when solving simultaneous linear inequalities. Okay. So practice now 2. We want to find the range of values of x for which it satisfies this inequality and this inequality. Okay. There is no substitution method when it comes to simultaneous linear inequalities. Don't have elimination method also, like what we did in set 2. Okay. So what we do when it comes to inequalities is that we will solve them individually. Okay, we have two inequalities to solve. There is the word and because they both must happen such that the result will satisfy for both. Okay, so we solve the inequality on the left first. We will have 2x less than or equals to 10 such that x is less than or equals to 5. For the inequality on the right, okay, we also do our usual solving. We get x more than or equals to -1. So this process itself is no different from what we have already learned how to do. Okay, just solve them separately. But because you're finding a common set of answers that will satisfy both, you need to interpret these two inequalities together. What do I mean? X less than or equals to 5 on the number line itself. I'll draw it up here so that all of us can see. Okay, x less than or equals to 5, let's say 5 is here. If I draw my number line, because it is less than or equals to, because of equal sign, it must be a closed circle. Less than will be any number towards the left. Right? For the second inequality, x more than or equals to -1. -1 perhaps is here. Okay, you don't have to draw an accurate number line. More than or equals to, so again, closed circle towards the right because more than. Okay, so the overlap in this case, which is here, will be the range of answers that will satisfy both inequalities. In other words, my final answer a value greater than -1, or in fact greater than or equals to -1, otherwise less than 5. So there is a lower bound number and the upper bound. So -1 less than or equals to x less than or